This is version 0.2.24 of SynthMaker, and I'm going to show how to create Euclidean rhythms with some new components. First I'm going to show an example that's already made, where you have here red, blue, yellow and green, like you have there, and you have steps, events and rotation for all of them. I'm going to play with it for a little while, and then I will explain how it works, and then I'll start from scratch. And this is the first time I used it, so I'll probably find issues on the way which I will fix for next version. So I'll put the volume up, and I'll go inside this module. So I'll put volume down. So at high level, this is what you would see. Most users, that's all they would see, unless you're a developer. And then you go inside and you have a lot of low level stuff, which is what I'm going to explain. Okay, so volume back up. I'm going to play a few notes. Okay, so these notes I'm playing, only the first four are affecting the notes that play, but there's also some drums playing, as you can see here. These drums are not affected by the notes I play, and hopefully that will become a bit more obvious when I start from scratch. So the Euclidean component is here. This is a module which I will make available with the app as well, or I might improve it a bit and then make it available. So when you go inside this module, it goes quite low level. So this is your red, your blue, your yellow and your green polyrhythms, or Euclidean rhythms. So for example, if we go inside the red, this is the actual low level component, which has these inputs: steps, events, rotation. You can pick a color, and this radius is for how far from the center they are, which I can show, like, so that these components are not connected. I'm going to delete them. So it basically needs cleaning up. Delete this. Okay, so you can use a color picker to give it a color. Like this is red. Could pick, green. Yeah, green is already used. I could pick some other color. Go back to red, and so that's your color picker. I've shown this radius slider and these three parameters, the steps, events and rotation. Like steps is at 8. You can see if I change it, it'll get more or less steps. And the number of events, you can see it also, now we have like 6, and this is rotation is at 0, and we can rotate it around. And when I do from scratch, that will become more obvious how it works. So this yellow stuff is what connects it to the user interface. You see it disappeared, now it appeared. And these purple ones are compiled code. So this is this here arrives a 0 to 1 angle, and So 0 is on top, and it gets to 1, it goes back to the top. And the output, actually, this output is not a float, it's a boolean. And also these connectors were a bit cleaned up and changed. So now you have a boolean and 16 booleans together, 16 doubles together, float, 16 floats together, an int and 16 ints together. This 16 is because there are instructions that can process all of them at the same time. So you get 16 for the price of 1. So whenever possible, I try to use them. Okay, so this red is also a module that has 3 sliders. Slider is one of the new components as well. So you have here the 3 sliders. This red component is actually also showing here on the right side. So a slider, for example, these events, you have a minimum value, a maximum value. You can give it a label for minimum and for maximum. You can have steps or not. In this case, I chose to have steps of 1. And you give it a title as well, like events. Also here, this is for your modifier, so you can do like padding, give it a border, give it a color background, etc. There's lots of modifiers that are coming, and they will be like Swift UI. So if you look at Apple's documentation for Swift UI, you will be able to understand these both the modifiers and these views. Like this slider is a standard Swift UI slider, so it will follow how they work with Swift UI. Now this component is also new, and I'm changing the names, the way the names work, where here you'll see E stands for event, it's all these green ones, while a C would stand for compile, so C underscore is event. And like this component converts from a event float to an event int, because you need this as ints. These outputs then go out on top. They're like these 3 here. If I change, you'll see the red going through it, and so they're used to program the low-level Euclidean component. So hopefully it becomes easy to understand that yellow is for user interface, purple is compiled, and these green are events. They only flow when things change, and they're normally related with user input, although not necessarily. Okay, so maybe there's also this component here, which takes 16 booleans and converts them to one of those that have 16 booleans together, so they can be processed together with one instruction. So in this case, these 4 Euclidean rhythms, they have a bool. This should be boolean, this should be boolean, this should be boolean. That's a mistake. And they come out, and they are controlling the first 4 of the 16 voices that are constantly playing. You can see here this is plugged to this component to show the booleans, and you can see only the first 4 are playing. So these first 4 that are triggered by these Euclidean rhythms, they then come out of here. So that output is the one here, this output, it's the only one inside. So this output is the one that comes there, and it's playing the first 4 voices. In this case, I'm setting the voices to these numbers. These are ints, and they correspond to here the loaded waves, loaded drum sounds. Now here on top also, this is MIDI to voices, so whatever I play comes out here, and it's connected to a car plus strong, which is receiving the same booleans, and so when the notes that I play that land in the first four voices, they also follow this pattern. Like I'll show that here. You'll see that only the top four will make it change. Okay. So what else? So in the future, these MIDI voices will have some kind of unison or number of voices, so it could make it just go through these four. But I think more interesting is when you'll have an unison of four, and each note you play will use four of these voices, so you'll have 4 times 4, and there will be a number coming out which will say which of those 4 voices in each note you play. There will be an index coming out which you can use to detune and change the voices, even the waveform that's being played, and so that way you'll have 4 voices per note without extra work. Or 8, or you could have 8 notes with 2 voices each. Anything that adds up to 16. So I think I might start from scratch now. So I'll just play a little bit more of this. And actually, before starting from scratch, the notes played go to car plus, which goes to a filter, which goes to a stereo delay, which comes out and is being added by the drums here, that I'm just controlling there the volume to make them lower, and then they go through a chorus. They're both added while they're all in 16 voices, and then it goes to the mono left and right channel with the sum component. And yeah, another thing I wanted to show is the way these 4 Euclidean components appear. It's like they're stacked with a Z stack, so they appear on top of each other. So like if I connect from here, you'll only have the red. If I disconnect from here, you'll have the red and blue, etc. And disconnect the green. But on top, there's this new component which is called the ZTO rotator, which stands for 0 to 1, and it has a start radius, which I will change here, and it a start radius and an end radius, which I can make it like this, for example, and hopefully this will be more flexible in the future, but for the moment it's just to indicate the current position of the Euclidean rhythm, and that ZTO comes from this component which converts from a C float to an event float. Like this connector here is actually one of those green connectors, and so this converts at something like 100 frames per second. The values come out because these compiled floats, they run at sample rate like 4400,000 or 48,000, so you wouldn't want them coming out for UI stuff. It would be too much. So here in the future you'll have like maybe an FPS number that you can set to control your frame rate. So this float that comes out controlling that thing that goes around is comes from a phaser. This is also a new component. There was a phaser, but it was for 16 floats, and this one is just for one float. And here is the frequency, which is running at 0.2 hertz. Actually, I will put the sound back and put the frequency up. So here, for example, if we have 1 hertz, 10 hertz, 100 hertz, and back to 0.2. And I'll change the dots again. Where is it here? So the car plus, I'll put the sound down again. So this car plus gives it a plucked sound, which doesn't sound very plucked because it's going through a filter. If I take out the filter and put the volume up, so that was your pure car plus, and now it's going through the filter. And I think I'll start now from scratch. So I'm going to close this. So now I'll start from scratch to create Euclidean Rhythms with SynthMaker. So I create a new document. I'm going to call it Euclidean 3. Make it bigger. And start with sine synth. And just to be easier, I'm going to use computer keyboards to play notes. And audio out, and now play some notes. Go inside sine synth. Now here we'll want to have some Euclidean rhythms, playing some drums. So I'm going to start with creating the drums with this component audio files, and I'm going to bring some drums into it. I need to get it with this. Yeah, so bring these sounds to there. Okay, don't need this. So this is our audio files that you can play with MIDI. I'm going to put the labels. So it needs a sample counter, which is where it's playing the wave, like which sample is playing. So the sample counter is, oops, not this one, sorry. Sample counter is sample counter there. So the sample counter needs like a gate so that it knows when to reset to 0, and that will be the beginning of when we play a note. So let's say if we play a note there, when we do Euclidean rhythms, this will be triggered by the pattern generated by the Euclidean component. So then we'll disconnect and connect the other one. But for now, for testing, we'll plug this. Also, let's see, we don't need the envelope, so we can connect directly to the output. And let's see, yeah, this is working. Now here, MIDI to voices has this note, which again we could look at if we show the ints here note. So when we play notes, I'm going to play some notes. It sets the MIDI note, which is same as pitch. And so if we connect this note to there, now we can play. Okay, so this is set up to receive our Euclidean rhythms later on. Now, for Euclidean, just to make it tidier, I'm going to create a module, and inside the module I'm going to create our Euclidean rhythms. And because I'm going to separate the different like I'm going to create like 4 patterns together, so each one will be its own module as well. I think it helps, and then I'll be able to copy and paste, so it will be easier. I'll just have to create one. So this one, let's say, will be our first one, and it will be this is the low level Euclidean, and if we connect to there, you'll see we'll have it there on top. And okay, so inside here we'll do all the setup for this pattern. So I'm going to start with the color picker, and connect it to there. And now here I'm going to set this color to red and opacity 50%. We can change that later if we need to. And I'm going to put the labels as well. So this yellow stuff will make it appear up there, and purple stuff will be compiled stuff, so it will have to come, it needs to know this 0 to 1 angle, so this will come from above. I'm going to give it like an input, so that they'll all, so all these patterns will receive the same. Also this is 16. We want just 1, 0 to 1, because this isn't per voice. This is just one pattern that will then control the voices. So now that we have an input, it appears here on top, and here we can start setting up how we control that 0 to 1. So if we have a phaser, there's this there's a new phaser which goes from 0 to 1. Actually, this here is wrong. This is a single float, not a single ball, because it's a value that goes from 0 to 1. Okay, so I'm going to connect it to there, and I'm going, actually okay, so here I need to give it a frequency, which will be C F. If I do a CF edit, so this follows the new naming. It's compiled, it's float, and this is the edit component. So I'm going to plug it there. Now to test this, I'm going to try this new component, which is called I think it's a view component, ZTO rotator, and if I bring a slider, might help. So slider goes from 0 to 1. The ZTO rotator has a 0 to 1 input there, which is what sets the angle. And when I change it here, you can see what it does. But this green stuff, it's like event driven, so data only flows when the value is changing, while this purple stuff, it's constantly running at sample rate. So we need a way to sample it, and there is a new component that goes from a compiled float, so from a CF, and it converts it to an EF. So it goes from compiled float to an event float, and it happens at I think 100 times per second, but in the future we'll be able to specify. So if we put it here, we can see the green component has gone red, meaning there's messages already flowing through it. And now if we set it to here, the, oh no, not this. This is set to 1. We want our phaser. It goes from 0 to 1 at 1 hertz. But if I put that 0.2, so now it goes from, that's 1 rotation in 0.2 hertz. Now we can set the start radius, and we can set the end radius. I'm going to leave it like that, and I'm going to save the schematic. Now this rotator, I'm showing it here, but where we'll want it is, it's at the end. It's like once we stack all these 4 Euclidean rhythms, these will be on top of all of them. But at least it shows that things are working. So that float, that goes inside here, comes inside there. So this is probably working. And this should generate a gate. And the gate, I'm going to make it go through this output. This now is a Boolean. And so as that rotator rotates on top of this, the gate goes up when there is an event, like an Euclidean event. So what can we do now? So here, I think for now I'll just have this red one, but we want to stack this rotator on top. So I'm going to put a Z stack to stack on top. So we want our red one, and we want this rotator on top, and you can now see it here. I'm also going to pin it to the right side because it's useful, and I'm going to call this Euclidean. So now we have this Boolean that must be going on and off. Let's see. We can display a ball, or I thought we could. So that's a component I need to make. So, but we can display 16 balls together. So if we convert now from a Boolean to a B16, oops, this is a bug. So there's this new component where we can now show the 16 values. And now when we connect this to the first one, you'll see it goes to 1 when here it hits the polyrhythm events. So this converted 16 booleans now can go out. So if we go to general output, and this is 16 booleans out, and now here on top this can go and control our sample counter. But if I'll need to play some notes to make it hit. So that happens to be playing whichever was the note I was playing, that MIDI note 69. It landed on the voice number 1. But to make sure it's always what we want, there's a new component called it's an edit for 16 values. And now this will, here we set up the MIDI note for each of the 16 voices playing. So rather than coming from our MIDI note, it will now come from here. So like if we set, for example, the first one to 60, I'm going to make it like 64. And back to 60. Okay, so we'll be doing the same for the other 4 voices. I'm going to put these, I'm going to name it notes, pin it to the canvas. So, and I will resize it a bit. So now here we could set this do anything. Now to control the Euclidean rhythm, that will be done inside here by setting up these steps, events and rotation. And the way I'm going to do that, I'm going to create a new module that does the three at the same time, because then I'll be able to copy and paste it. So it's useful to keep it separate. Also here I'm going to put this node to 0 so we don't hear it. Okay, so here we'll need 3 sliders. Let's go slider, 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 slider. I need to do a search. I need to implement a search to make it easier to find. So this first slider will control steps, and then I'll do events and rotation. So this is steps, and steps, let's make it go from 1, maybe 1 is pointless, to let's say 16. From 1 step to 16, we can make it go in steps of 1, so our slider can go in steps of 1. And also we want to show the minimum and the maximum, so now it shows there from 1 to 16. And now actually I'm going to call this I don't need to, no, I'll copy and paste. And now this second one is from steps, we go to events, and this will be events. Events, we might want 0 events, so we don't hear anything, and to 16, which is all of them, and that's our events. And now rotation. Rotation, we start at 0 as well, no rotation, and we go to 1 minus the last one, because the last one would be the same as 0. And now we have rotation. Now we want all these 3 stacked, let's say vertically stacked. So we go here, views, Z stack, and connect like this. Okay, now we have our, no, not Z stack. We want a Z stack. Z stack. Connect them like this. Oh, did it again. Whoa, we want a V stack. V stack, there. Okay, now it should work. Yeah, so now they're aligned vertically. And this will be for our red component, so I'm going to name it red. And I'm going to pin it to the right side so we can control it there. And could give it some padding, but here I think, let's see if that works. Modifier, padding, is it work? Nope. Okay, that's a bug. So this should give it some padding, but modifiers are not implemented. Okay, so what now? So we need to plug these there. So we need here 3 outputs, and also here comes a float, and we need int. That's like an I. So we need to convert our floats to int, like this. And now we need 3 outputs, which is in like general output. This output will be a green int. Now normally I'd copy and paste, but when I do that they don't appear on top. Need to fix it, so I'm going to do, I'll have to do it 3 times. So int and int. Okay, And now we can plug these to our steps, events, rotation. Now I can put back that, and now here we can have many. Let's have more events. So that's number of steps, number of events. I need to put here a label showing how many are set up at the moment. Rotation at 0, etc. Put rotation at 0. So there's also this radius. I'm going to give it another slider, and you can see there this radius. We can set it to so this way we can have several together. And now we can copy and paste and create some more. So let's do it here. Okay, now this red one, copy and paste, make this one appear next on top, and then the line on top of it. I'm going to give it a higher rotation, a higher radius, or actually the other one should have a higher radius, so we'll start on the outside. So this one would start on top, on like there. Second one will be, let's say, blue, and the rotation, let's make it near the red so we have space for some more. And the boolean, so this needs also to be controlled by our 0 to 1. And now we'll make the second channel use this one, and 61. Now there's the two are going at the same time. I'm going to put volume a bit lower. So the two are going at the same time, so we need to change the here this is now called blue. I'll pin this to the canvas because this was copied from the previous one. It has the same values, but we can now change it. Let's go like volume up again. That should show 63 there. There must be a bug as well. Anyway, so I could continue, but this is basically it. Maybe I'll do one more. So rather than do the 4, so this is only using 2 of the voices, which is a little bit of a waste, but you know, 16 voices processed like in one instruction, so it's fine. Okay, so again, another one. Now we'll make this one go on top. We'll give it a lower, give it a different color, like yellow. Come on, yellow, 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 yellow. And now this was copied from the blue one. This is now called yellow. Good, pin it to the canvas. And now we can control the yellow and give it a sound. It's 64, I don't know what it is, let's see. Oh, it's not plugged either. So here, the boolean that comes out will then need to go to one of those there. To give it something different. A bit of rotation as well. Okay, now for the frequency, again we could change the frequency that it is playing at. Okay, so this is controlling drums, but we could also make it control like our synth. So here I'm going to add the two, or no, let's just go for the synth on its own. So now we have the synth, but instead of controlling the gate of the ADSR with the gate from our note, we can control it with the gate from our polyrhythm. And now when I play notes, they fill the 16 voices, and then they get played. I'm going to show with this showing the booleans. So this will show the notes when I play them, and the first three, now they're all the same. I'm going to play different notes, maybe an octave above. So now the next one, and the next one, and the next one. Okay, so let's change the red. We could mix them by doing like a float add, so we can add our notes playing with the drums. And then I can keep refreshing the notes. So every time it hits the first three, it sets the notes that get played. Also here we could, instead of 66, go 67. Now it's playing, etc. And so that's the basics of doing Euclidean rhythms. Of course you could stack like 16 of them. Without, the performance would be almost the same, although 16 is probably too much. You could like make them go a bit more together, like let's see here, this make the blue very near the red, and then the yellow very near the blue, etc., and stack 16 of them there. And also this will need some kind of controls that will appear on top. So at the top level, actually I didn't put it there. So in our synth we would want to see this. So now it appears. This is again what most people would see would be just this. But it will need to have some kind of controls, or maybe something that you click on and something pops up which allows you to set these steps, events, rotation, etc. Might have a little stepper with a plus and a minus, show you the value, and that will be done with UI controls that will come soon, and you'll go down here and create your modules. And this is quite a bit of work, but it's like a lot less than writing the code, like a big difference. And once you have your module, you can export it, export here, and reuse it. And I think soon there will be a way that you'll be able to drag it somewhere, and it will become available on your menu as your own custom modules. So there's probably a lot I forgot to say, but maybe for another video.